Alright, let's take a look at some of the more advanced problems using special right triangles then. We want to solve for x. We're given that we have the hypotenuse of the first triangle as 4, and this little marking here says that each one of these angles are 30. So that tells me that each one of these triangles are 30, 60, 90, and I need to solve for each one of these sides here to get to x. If I put in alternative variables like for instance z and y, I need to know what the values are for z and y in order to find out what x is. If I take a look at my special right triangle mapped out like the picture, I have 30 here, I'm going to have x, 2x, and x square root of 3. To solve, I'll have to take what I know, which is that 4 is in the same spot as the 2x, so therefore 4 is equal to 2x. That means that x is equal to 2. So that means that this side on the right here is 2, which means that this side here on the right is 2. And that leaves me with z, which is in the same spot as the x square root of 3, will be 2 square root of 3. Now I need to repeat the process. Now that I have z being 2 square root of 3, this is really in the same spot as the 2x on the next right triangle. Okay, so if I map it out in green here in the middle, the bottom now becomes the hypotenuse of the next one. So I have 2 square root of 3 equal to 2x. Solving, I divide 2 on both sides. I'm left with x is equal to the square root of 3. X is in this on the right side, so that means that on the right side here, this side is square root of 3. Y is in the same spot as x square root of 3 on the special right triangle. So therefore, I'm going to take what x is, which is a square root of 3 for this one, and multiply it by the square root of 3. So it looks kind of weird, but it'll be the square root of 3 because that's what x is, times the square root of 3. We put that together, that's the square root of 9, or just 3. So that means y is 3. 3 is now in the same spot as the 2x, so therefore we have 3 equal to 2x. We divide by 2 on both sides. We have x is equal to 3 over 2. And then once we have x equals 3 over 2, we know how this is going to be the input for the x square root of 3. So our final value is x is equal to 3 over 2 square root of 3. Alright, next problem here. We need to solve for both x and y. And x and y are in a combination figure with both of our special right triangles. We know that this angle here is 45 degrees as well, giving us the 45, 45, 90. And if the 60 degree angle tells us anything about the left triangle, that is that this angle up top here is 30 degrees as well. So we really have two situations to solve. The first one is that we have a 45, 45, 90 triangle. So we'll have x, x, and x square root of 2. We're given that 4 square root of 2 is the hypotenuse in this figure. So therefore, by simply solving, we have 4 square root of 2 is equal to x square root of 2, which leaves us with x is equal to 4 as our value. And that'll be this side here. Okay, that's nice. That's the easy part. But now what we need to do is turn this figure up on its side to give us this 30, 60, and 90 triangle, where we have 30 down here, 60, and we have x, 2x, and x square root of 3 to solve. What we're really given, if this is the bottom right here, where the 4 is, that's this spot down here, we have to state then that 4 is equal to x square root of 3 from our special right triangle. Solving then, x is equal to 4 over the square root of 3, and you multiply top and bottom by the square root of 3. So simplifying, then we have 4 square root of 3 over 3. That is the value of the x side, which is the one across from the 30, which is across from the 30 here. So we know that this is equal to that. And the final value we're trying to solve for, y, is really the hypotenuse of that 30, 60, 90 triangle, which is 2 times x. So if x is equal to 4 square root of 3 times 3, then 2x is equal to 2 times what x is, which is 4 square root of 3 over 3. So our final value for y is really equal to 8 square root of 3 over 3. Final answer for y, final answer for x for the problem. So again, this one combined both the 45, 45, 90 triangle and the 30, 60, 90 triangle. Alright, last question that we're going to handle. Given the diagonal of a square to be 14, what is the perimeter of the square? Sketch a picture and solve. So we have a square. The nice thing about a square is we know that all four sides are the same. We know the diagonal then is going to be 14, and it's asking us what the perimeter is. Well, we know that squares have 90-degree angles, and seeing as how we have all the sides being the same, we know that when we have a triangle being cut across, it's an isosceles triangle, so therefore the triangle must be a 45, 45, 90 triangle. So we're going to have x, x, and x square root of 2 as our reference triangle. 14 is in the spot of the x square root of 2. So as I'm solving here, I will have 14 equal to x square root of 2. X then is equal to 14 over the square root of 2. Multiply top and bottom by the square root of 2. 14 square root of 2 over 2 is my value for x. And that's my side. I simplify that down further, and I really have a nice number of the side length being 7 square root of 2. There are 1, 2, 3, 4 sides to my square, so therefore I'll take 4 times 7 square root of 2 to find my perimeter. So my perimeter, final answer, 28 square root of 2. That ends the lecture then for today. Things that we're going to cover and go over in practice will be page 556, numbers 1 through 33, 37, and 38. And again, that's with no decimals, all with exact values. And we'll also take a look at worksheet 8.3. Thanks for watching.